Solve the following absolute value inequality. Write the solution set in interval notation, and then sketch the solution set on the number line. And here we are given the absolute value inequality, 3 times the absolute value of 5 minus x plus 2 is less than or equal to 14. So let's recall that when we're solving absolute value equations, the first thing that we need to do is isolate the absolute value. So looking at our given expression, in order to isolate the absolute value, we'll need to first subtract 2 from both sides, and then afterwards we'll divide both sides by 3. So now that we have isolated the absolute value by itself on the left-hand side, we want to go ahead and use the properties of absolute value inequalities to rewrite this absolute value as an inequality without the absolute value. So recall that for some non-negative constant k, when we have the absolute value of x being less than or equal to k, this is equivalent to the inequality where x is greater than or equal to negative k, but less than or equal to positive k. So applying this property to our absolute value inequality, we have the following. So now that we have rewritten this expression without the absolute value, we can officially begin to solve for x. Now let's pause for a cause here and be careful. Notice the coefficient on x is a -1. So when we go ahead and divide each part of this inequality by -1, recall that when we multiply or divide an inequality by a negative, it's going to flip the inequality symbols. So dividing each part of our inequality by -1, the symbols or the inequality symbols get flipped, and we are left with a solution set where x is greater than or equal to 1, less than or equal to 9. Now don't forget, this question's asking us to write our final answer in interval notation. So this is an inequality form, and the equivalent interval, we can say that x is an element of the interval from 1 to 9. And notice that we're using square brackets at these endpoints to indicate that x can equal these values. And last but not least, we want to sketch the solution set on a number line. So here's our number line, our x-axis, and we really only need to be concerned with the endpoints of the solution set. So +1 and +9. And since x can equal these endpoints, we'll draw closed circles at each endpoint, and x can be any value in between.